How does dirt and rock turn into gold bars, copper wire, and iron pellets? This whole process happens in a mine and in a series of ore processing plants, often near the mine. In this video, I'll walk you through this whole thing from the mine face all the way to the shipping port. So let's get started. In this area called Gold Quarry, the gold is pretty close to the surface, so they just started to dig up the ground and then sluice out the gold. But after a few years, the high-grade gold was harder to find, and prospectors started to look underground, where they found really rich deposits. Over time, this area has turned into a collection of above-ground mines, underground mines, and many types of ore processing plants. It's the perfect place to learn how mines work, how dirt and rocks turns into gold bars and copper wire. So for the next few minutes, we'll use this map to walk through each step in the process. Let's start with mine planning. Before any bulldozers and haul trucks show up, the geologists and engineers are busy making a plan. They drill a lot of holes to get core samples. And then when they put these samples into modeling software, they get a pretty clear picture of where the best deposits are. And they pick one of those deposits to start with. Based on the location and shape of the deposit, they decide on the type of mine they will build. And the whole mine plan is put together, from the first shovel in the ground all the way to closing the mine and restoring the area back to its natural habitat. Generally speaking, mines fall into two categories, either above ground or below ground. Let's start with the above ground mines, and I'll walk through the whole process using Gold Quarry. Mining always starts with an explosion. If we look at this mine, you might think that we're working at the bottom of the hole, but digging always starts at the top and then works its way down the side of the hole, one level at a time. So we could be working anywhere along the side of that hole. First, they drill a pattern of holes into the ground to put explosive powder into. You can see the drills here and how they've already drilled a lot of holes. Once they're done drilling, a special crew comes to the area and they put in specific amounts of powder into each hole. And then they wire up each hole for detonation. After all the preparation, they clear the area and they set off a beautifully orchestrated explosion. After the explosion, they're left with a bed of broken rock that can be loaded into trucks. Typically, there's a whole fleet of trucks that forms a circuit between the shovel that's loading the rock and the crusher. In this mine, that trip looks pretty short, but it's not uncommon for haul trucks to travel 45 minutes from the time they're loaded to where they unload. Today, most trucks are driven by human drivers, but an increasing number of haul trucks are becoming autonomous. That means their route is programmed into the truck's operating system, and the trucks can drive from one location to the next without a driver on board. In an above-ground mine, these trucks are often the size of a 3-story house and can carry between 200 and 400 tons of rock. The rocks in the bed of these trucks can still be quite large, even though they've been through an explosion. Because of that, trucks often dump their load into a large rock crusher that breaks apart the rock like a coffee grinder working on coffee beans. Coming out the bottom of the crusher, the rocks are smaller, and small enough to be easily handled by a conveyor belt. Conveyors are an efficient way to move a large continuous amount of crushed rock. Some conveyors transport the rock from a crusher like this one all the way to a processing plant nearby. But in extreme cases, conveyor belts can be many miles long, like from the processing plant to the dock or from one mine to another. The longest conveyor system is at a mine in Morocco at 61 miles long. Now at the other end of this conveyor, the ore reaches a series of processing plants. If the ore is made up of hard rock, the first plant is a ball mill. This is a system of large metal drums with steel balls inside that rotate and pound away at the rocks until they turn into a fine dust. As you can imagine, this makes a pretty big racket. Next, the dust is transported to a separation plant of some kind. Separation can happen in a roaster, an autoclave, a leach heap, or a bubble concentrator. I'm sure there are other kinds of separation, but you get the idea. The valuable bits of the dust need to be separated away from all the other parts of the dust, and then they're sent to a refinery or smelter. In this last step, the refinery or smelter does a purification of the product using a furnace. This step produces small pellets or bricks or bars that industrial companies buy for further processing. At this point, we have a product that the general market buys for manufacturing or some other type of commercial enterprise. Okay, deep breath. That was above ground mining. Underground mining is surprisingly similar, but in underground tunnels. Let's have a quick look so that you have a reference of that as well. Hang on, here we go. Deep under the ground through a maze of tunnels, and then you get to the face where the mining starts. Same as above ground, it starts with an explosion. In this case, the drills put holes into the rock in multiple directions because the tunnel is surrounded by valuable ore. When the explosion experts have wired up the explosives into the holes, they clear the area and kaboom! The loaders pull in and load up the rocks and put it into trucks. The loaders and trucks are much smaller though, because they need to fit into these tunnels. The trucks haul the ore to a crusher nearby, or they dump it in a chute that's been carved out of the rock, and that takes it to, well, closer to the crusher. And then once the rock goes through the crusher, it drops onto a conveyor belt just like before and takes the rock to the surface. From there, the ore goes through the same processing steps that we had before. Hard rock gets pulverized in the ball mills and then separated in some kind of separation process and then off to the smelter or refinery. From there, it's off to a shipping yard where it's loaded and sent off to an industrial customer. And that is how a mine works. But there's one more thing I think you'll find interesting. For many years, all the vehicles and machines in the mine were set up to deliver on the designed mining process right from the beginning. Operating the mine to capacity and performing maintenance was heavily dependent on the ears and eyes of the mine workers. They were the ones who knew when things started to go wrong. But this is all about to change. Increasingly, every machine in the mine is being measured by sensors that transmit data back to the operations center. When a bearing starts to heat up or vibrate, sensors pick it up. Computers are helping to identify fatigued operators, flag ore that's been dumped in the wrong location, and even sort ore by grade level for efficient processing. And there's so many more things. The sensor data that's required to make these decisions travels across a sophisticated communications network in the mine. Cisco Systems, the company that I work for, helps mining companies every day to ensure that operators get the right data at the right time. In summary, mines start with rock and dirt, sometimes deep below the Earth's surface, and then they transform it into products that we use every day. Thanks to modern data and computer systems, this process can happen more efficiently, safer, and more sustainably than ever before. Take care.